we have the 6-meter invitational net on our 6-meter repeater, and it's been growing a bit. We're getting sometimes 14, 15 check-ins. So join us on Sunday morning at 10 o'clock, and it's kind of fun. Also, I've got a UHF repeater on 4489 or 75 that I link over to the 6-meter repeater via All-Star, a direct link. So if you should have any problems, you can always go over there. Or if you don't have a 6-meter radio, you can go over to my repeater and link in on 6 meters. So it'll go both ways. So it's kind of a fun net, nothing formal about it. And just check-ins and general information. So Sunday morning at 10. I don't have anything else for the club. We will be, Mark and I will be up at the Hamfest on Sunday, and we'll have 2 tables, and we'll have some of our DRC goodies for sale. So stop by, see what we got, and at least say hello. And we'll be up there for the Hamfest. And
you want to mention the door prize, Jerry?
Oh yeah, well we do it tonight. We do a door prize for a $25 certificate at HRO. So towards the end of the presentation, Jeff will electronically draw what you need to do. He will put up the link on the chat. We'll let you know, or he will, when we do that. And you just go in there and click on the link and register yourself, and then the software stirs up the names and picks one random. So that's tonight. We'll do that at the end of the net. So with that, I'll introduce Carl, our presenter tonight, and K9LA. Carl's a very well-known ham, and he's going to talk to us about 2 simple HF antennas and some things about those, and some other modeling software, and kind of the propagation advantages of different modes, CW, sideband, FT8, and etc. So, and also if you take QST, which I hope everybody does, if you look on page 70 of this month's QRT, you'll see an award on there that Carl received. So go into March, the March QST, and take a look at page 70, I believe it is. And with that, Carl, I'll turn it over to you. Please tell us a little bit about yourself and some of the stuff you've done, and carry on. I guess we'll go about an hour, and then I don't know how long you planned. That works out pretty well, and then we promised a Q&A at the end there. So it's all yours. Thanks in advance, and go right ahead.
Okay, thank you, Jerry. I'm Carl, K9LA, in Fort Wayne, Indiana. It's up in the northeast corner of the state. Yeah, I think Monday night, Jeff and I got on, and we had all kinds of problems, or at least I did. My computer, my desktop ran slow, my laptop ran slow, so I was kind of worried. Then we got on last night, and everything worked just perfect, and I really didn't do anything, so maybe it was an external problem here, whatever. Yeah, I've been a ham since October 1961. That's when I got my novice license. So I've been around the block a couple times. Okay, more than a couple times, several times. And I picked up K9LA in 1977 when they allowed extras to select 1x2s. And that was a good thing. And I kind of didn't want to give up my old call, but I'm glad I did now, I guess. I'm a graduate of Purdue University, double E. Back when, almost back when dinosaurs roamed the earth. I graduated in SEE in '69 and MSEE in '72. And I'm retired. I retired in 2013, and I was an RF engineer for Motorola for 14 years, and then Magnavox Raytheon for another 25 or so years. Mostly I designed solid state RF power amplifiers for commercial job. Got to admit, it was fun, but when I hit 66, I said, that's enough. Time to go do some other stuff. My wife is Alpha Echo 9 Yankee Lima, Vicky. That really helps to have your wife. She's a teacher. She's winding up her career. She's teaching at an elementary school. She enjoys science, and we both enjoy traveling. And just got back from the ARRL National Convention in Orlando, Hamcation, over the weekend. And I can tell you that the weather down in Orlando is a little bit better than the weather up here in Fort Wayne. So I enjoy DXing, contesting, trying to figure out propagation. Playing around with antennas. We live in a somewhat rural area on a couple acres, so we can do anything we want. And I also enjoy vintage equipment. If I move out of the way, you can see there's a Ranger 2, a Viking Ranger 2, and then to the left of it is a Drake 2B receiver. So that's a fun setup to use, and it was a good station back in the early 60s, and I still think it is a good station on CW. Okay, let's see if I can share my screen without having problems. Of course, I hit the wrong thing there. Okay, here we go. Share a will. Let's see if it comes up. Yeah, it did. How about that? Oh, there it is.
Hey, we're not seeing it here, Carl.
Okay, it just came up for me.
Help, Jeff.
Yeah, it may take a little bit, but it should come up.
There you go.
I hope.
It's coming up now. There
Okay.
it is.
Okay, now let me go to, let's see, how did I get it to full screen?
Control L.
Control L, that's
Control L,
right. Yeah. Okay. Okay, it's just came up full screen for me. So
Looks good here.
let me know when it comes up.
Yeah, we're good
Pardon?
here.
Ah, great. Okay,
Good.
so that's who I am. There's my email at aol.net and my website, k9la.us. And I'm going to talk about two simple antennas for HF. There's lots of, well, really, when you think about it, there's a lot of simple antennas. So I chose two of the, probably the most well-known. And why I put this presentation together is because Cycle 25 is starting its ascent, and pretty soon we're going to have some very good worldwide propagation on 15, 12, and 10 meters on a daily basis. Not on a daily basis yet. Still kind of iffy, but we'll get there, and it'll be very interesting to work the world on modest power with a modest antenna. Now, I don't know how many of you are have been on HF for a long time, or any are new, so maybe some of this is a little bit already known, but we'll go through it anyway. Let's see here, see if it works. Okay, I'm going to go over what we're not going to cover. Then I'll look at vertical antenna performance on 2015 and 10, a contest. Then I'll look at a dipole or an inverted V. They're very similar, of course. Performance on 40 and 20 in a contest, and performance on 160 in a contest. A contest is a great way to evaluate your antennas. Then I'll have some comments about antenna modeling, and I'll do a summary, and then I have 2 slides on the status of cycle 25, so you see where we are right now. Okay, these are the antennas that I'm not going to cover. These are big antennas. Way on the left is OH8X in Finland. It came down in the weather, but it was 3 elements on 160 meters and 5 elements on 80 meters. It was up there on a huge tower. You can see that the boom was tower sections. Unfortunately, it was too big for winter up in northern Finland. The top in the middle is a 9-circle array for 160. There's 8 antennas around the perimeter and 1 in the middle, and they're used for gain to come up with a nice unidirectional pattern, which also helps on receive. And there's some monoband 80-meter antennas. Not too many people have those kinds of antennas. We're not going to talk about this. We're going to talk about 2 simple antennas for HF. So here's my vertical. I have a Hustler 4 BTV. The BTV, 4 BTV stands for 4-band trap vertical. It works on 10, 15, 20, and 40 meters. It's only about 18 feet high, so it's very nice for a small city lot. Of course, it will help if you put radials on it. And there's a common perception that a vertical radiates equally poor in all directions. And if you don't have a good ground system, that can be true. But if you put some radials on it, you'll have very good results in a small footprint too. So here's a patterns of the 4 BTV. Patterns come from the antenna evaluation software 4NIC2 by Ari Vors. It's free, so that's why I use it. Of course, the vertical, the azimuth pattern, in other words, going around the compass, should be omnidirectional. But that could be modified by metal structures of appropriate lengths in the close to the antenna, especially if you're on a city lot with maybe a house with metal siding and also a garage with metal siding, aluminum siding. And of course, the elevation pattern depends on the number of radials and your ground conditions. On the left is the model of the 4 BTV 20 meters with 2 radials, 1 foot above salt water. And you can see that it puts radiation at very low angles. The max gain is about plus 4 dBi at about 10 degrees. So that's a very good performer if you can put it by salt water. And you can understand now why DXpeditions like to use verticals on the beach near salt water. It gives them very low angle radiation, which is good for long distance contacts. Now, if you put that same antenna over average ground, again with 2 radials at about 1 foot above the ground, that's what the pattern looks like. You can see that we radiation at extremely low elevation angles. The max gain is about minus 1 dBi, and it peaks up a lot higher, up at 25 degrees. The gain is about minus 4 dBi at 10 degrees. So if we compare that to the gain over water, when you put that vertical over average ground, you're going to suffer about a S unit and a half at low elevation angles. Now you may think that's a lot, but if there's a guy coming in at S9 on the saltwater vertical, okay, S7.5 on the average ground vertical, that's not too bad. And you're able to work lots of people as you sit in the chair and pay a lot of attention to what you're doing. Okay, so here's some comparisons, or not comparison, but some performance in the real world. I did ARRL DXCW contest in February 2002. Whose sunspot number was about 115, so that was the around maximum of cycle 23. So you'd expect the higher bands to be pretty good. I just ran 100 watts to the 4BTV. I mounted it temporarily on our single storage garage roof, and I had 2 radials for each band. I only did 20, 15, and 10 because having the 40 meter extension on made it kind of wiggly, and I was worried the thing would fall over. I didn't use an amplifier, didn't even look at packet cluster to see who was on. On Friday evening, I played around from 7 till 10 p.m. I worked 42 countries. The best was 9H1 Zulu Alpha on 20 meters. Not too bad. Saturday, I had 3 3-hour periods, 8 to 11 in the morning, 1 to 4 in the afternoon, and 7 to 10 again at night. I added 41 more countries, so in a total of 83 now. Some of the ones that stood out is YB0, Indonesia on 20, Jordan on 15, and Lebanon and Hong Kong on 10 meters. So the bands were good and the vertical was doing very well. So I had to get on Sunday also. I had another 6 hours and 4 more sessions. I only worked 8 more countries because it was getting harder to find new countries. Remember, I'm not looking at packet. What I'm doing is tuning band, identifying who it is, and then checking to see if that's a new country for me. So that put me to a total of 91 countries. And on Sunday, the best was Oman, and EX is Tajikistan, I think, on 10 meters. Or Kyrgyzstan. Wow, one of the stands out there over there.
What mode
Now,
was all
since
this,
I was
Carl?
only running 100 watts to a vertical, pardon?
What mode was all this?
Pardon?
What was the
CW.
mode you were using? Were you
All, yeah, CW. Okay. Are you still there?
Yes, copy.
Okay, all right. This was all CW. And again, using the vertical and 100 watt, there was a number of stations I couldn't work because the pilot was just too big. But that's the way it goes. And most of the contacts were not me just getting my call once and I was in the log. I had to really work at some of them. But that's okay. When you're running 100 watts to a modest antenna, that's about it. So I ended up with 91 countries. I could have worked W and VE, but the object for me was to work in DX countries. So I could have worked a total of 93 countries for an 18-hour weekend effort. And that's not too bad. Just shows you lots of DX can be worked with 100 watts on a simple vertical. And of course, it helps when the sun cooperates by having lots of sunspots so the higher bands are open. Okay, the second one's a dipole. Pretty simple. That's what I started out as a novice, and it did wonders for me. It works on the fundamental frequency when it's cut for a half wave, and approximately 3 times the fundamental. So a 40 meter antenna can be used on 15. With the modern solid state rigs, you might have to use the internal tuner on 15 or an external tuner. This would also work on 160 and 60 meters, and also 80 meters and 30 meters. So, cut it appropriately As you go up in frequency, of course, the antenna gets smaller. 40 meters, the overall length tip to tip is about 66 feet. 20 meters, overall length is about 33 feet. 15 meters, about 22 feet. And of course, on 10 meters, it's about 16 feet overall. So it's pretty manageable as you go up in frequency. And when we get to a good point in cycle 25, I'm sure you'll be on 15 and 12, or 10 and 12 and 15 meters quite a bit. Now, one common perception for the dipole is if it's at low height, it's a cloud warmer, and it doesn't allow you to work any DX. So let's look at the patterns of a half-wave dipole. On the left, this is a 20-meter dipole. It's at 66 feet, which is 1 wavelength high. The red pattern on the left is the azimuth. The blue is the elevation. Now, this is over average ground. As you can see, there's a nice null off the ends when you're looking at the azimuth pattern. The big thick red line is the orientation of the antenna of the dipole. And the max gain's about 7 dBi at 15 degrees. So that's a pretty good thing. Now, what if you mounted it only at 8 feet? Well, you can see what happens. It turns into an omnidirectional antenna. You can see that because the red is a pretty good, pretty perfect circle around the end. And the elevation, well, most of the radiation is kind of upwards at very high angles. The gain's only minus 5 dBi at 15 degrees. So if you're comparing a 20-meter dipole at 66 feet to a 20-meter dipole at 8 feet, you're going to see about a 2 S-unit difference. Now, that's may not be too bad. Again, if he's S9 on the antenna up at 66 feet, he'll be about S7 on the antenna down at 8 feet. So that's giving up a lot of dB, but you can still work people. You just might not be the first one in line. Now, a dipole needs 2 supports. So that's why I usually favor an inverted V. You don't need 1 support. Performance is similar to a dipole, and just caution, try to keep that angle between the sloping wires greater than 90 degrees. So I had a 40-meter, 20-meter inverted V with its apex at 40 feet, so that wasn't too high. And I again jumped into the ARRL DXCW contest in February 2009. The smooth sunspot number was 1.9, so that was solar minimum. So that's why I chose 40 and 20 meters, because I figured 15 and 10 just wouldn't have much of anything. I also penalized myself by using my Viking Ranger 2, about 50 watts out, and the Drake 2B. Again, no amplifier, no packet cluster. I had to tune the band, identify who I was working, and then decide whether I wanted to try and work them. Well, for the weekend, I ended up with 79 countries using that simple inverted V with some vintage equipment. And again, it just points out that lots of DX can be worked with low power and a simple antenna at a reasonable height. Of course, you may have to move down in frequency if you're at solar minimum, but 40 and 20 are very good bands to do that on. Now, 160. Well, I have a 160 meter inverted V at 45 feet. Okay, and there's a comparison to the inverted V at 45 feet to a very good vertical. Red elevation pattern is for the inverted V at 45 feet. The blue elevation pattern is for a good vertical. In other words, a quarter wave with a good ground system. You can see what the difference is there. Most of the energy for the inverted V at 45 feet goes straight up, and it's at a deficit at low elevation angles where most of the DX is. Again, it's about 2 SU difference in favor of the good vertical. Again, you may not be first in a pilot, but you can still work other stations, including DX. So here's some performance from the inverted V at 45 feet. This was the ARRL 160 meter DX 160 contest in December 2019, not too long ago. I was running 1,000 watts using an amplifier, and I had a shared apex loop for a receive antenna, which helps improve the signal to noise and receive so I could hear better. And the 160 meter inverted V had bent ends because that's what allowed it to fit into the property. And again, I worked 49 states with that low inverted V. I missed Alaska, but I found out later that looking at the reverse beacon network results, I was heard in Alaska. So I say I'm 1.5 states. Oh well. I did work some Western Europe and some Caribbean. Of course, the amplifier really helps on 160. It even helps if you got a good vertical antenna. Again, lots of QSOs with a cloud warmer antenna. So put something up, give it a shot, and see what happens. Okay, I mentioned 4NEC 2, and there's the U. Jeff has a copy of this presentation, and he can send it out to whoever or whatever. Again, 4NEC 2 is free, uses the numerical electromagnetics code. It comes with the NEC 2 engine, which has some limitations, but is adequate for most amateur radio scenarios. There's a NEC 4 engine, which remains proprietary. You have to buy a license for it, then you have to buy the software. But then you can bury wires and connect wires to lossy ground. So that's good for modeling beverages and verticals. Just a general statement about modeling. If the modeled results seem too good to be true, they probably are too good to be true. So it's always good to have an idea of kind of what the antenna is going to do. You know, have some reasonable expectations. And if the model comes out close to that, you're probably safe in assuming that, yeah, the model is doing pretty good. And here's also some other antennas I'm just playing around with. On the left, I have a 3-element 6-meter MFJ Yagi, and it's at 30 feet. It's only a 6-foot boom. The elements are about 10 feet long, so it's pretty small. It fits on a city lot very nicely. And during summer months when we have sporadic E, it's a great performer. You can see there's the azimuth pattern in red. You can see it puts most of its energy on the nose, and therefore you're going to need a rotator depending on where the signal's coming from. The blue is the elevation pattern. The first null is down around, let's see, it's about 10 degrees. And 30 foot's a pretty good height for a 6-meter antenna. You'll have lots of fun working everything. Hopefully cycle 25 will give us some F2 propagation, some propagation via the F2 region. So you just have to rely on sporadic E during the summer months. In the middle is my main HF antenna. It's a Tenadyne log periodic dipole array. It's called, it's a T6. It covers 14 to 30 megahertz. It's a 12-foot boom. And it's just got six elements. It's about as big as I'd like to put on my 60-foot self-supporting aluminum tower. And it works very good. At the bottom, there's a picture of a log periodic antenna looks like. That pattern is at 50 feet, and it has reasonable front to back. You can see the red azimuth pattern has a major lobe towards the front, and it's still got some energy off the back, which can be helpful at times. And the elevation pattern in blue at 50 feet on let's see this is on 15 meters. 50 feet has a major lobe at about 15 degrees, which that's pretty good for working long distance stuff. On the right, that's the Radio Moscow 40-meter Sturbican. It has 4 rows of dipoles, and there are 4 dipoles in each row. And there's the height, 30 feet, 99, 168, and 236. That's the heights of each of the rows. And you can see what the pattern looks like. Very good, lots of gain. It's about an S unit more than the other 2 antennas. And I believe they had a reflector in back, so it was more unidirectional than anything. And they could vary the phasing to do a little bit of elevation angle control too, so to maximize their signal over into their target area. Playing with models is lots of fun. Again, if it appears to be too good to be true, it probably is. So just make sure you apply sanity to your results. So dipoles and inverted V's and verticals can provide lots of context and lots of fun. You have to get on the air and there. So get on the air, stay in the chair. And if necessary, you can bend the dipole inverted V, the ends to fit on your property. It won't to make a major difference. There's a lot of other simple antennas, like the end fade half wave seems to be very popular nowadays, G5RV. There's a ZS6 BKW antenna that's pretty interesting on how it works. And I know you had showed the, I think the 20-meter and homebrew 20-meter antenna. So that's pretty simple and it worked. I just got to get on and do some more work with it. I also believe operating skill is just as important as the antenna. So get on a radio a lot, play around, and you'll be able to do a lot. And of course, use the digital modes, especially on the higher bands, 15, 12, and 10, because cycle 25 isn't at maximum. FT8 has an advantage over CW, about 9 dB. That's a huge amount. And it has even more advantage over sideband. FT4, that's a little bit faster mode, and it gives up a little bit in decoding ability. So the slower the digital mode, the better the decodability into the noise. So, well, whatever antenna you have, just get radioactive. That helps a lot. So, I'm aware of 56 predictions for cycle 25. Why are there? And that's because we just fully understand what generates solar cycles. And because of that, we end up with lots of predictions. The predictions ranged from very low to very high. This is the prediction for cycle 25 from NOAA. And there's the URL where you can look at it. There's something funny about their plot. If you look at where their red curve begins, it began May 2020, but solar in between cycles 4 and 25 was in December 2019. So you really need to shift that red curve over to the left 5 months. And what that does is it looks like cycle 25 is pretty much tracking that prediction in red. On the left is cycle 24. The black data is the monthly mean. In other words, the monthly average sunspot number. The purple is the smooth number. In other words, you take 12 monthly means and average them. And of course, what that does is smooths out all the spikes in the monthly mean data. You can see cycle 24 had 2 peaks. So did cycle 23 and 2022. The reason for that is the 2 solar hemispheres aren't working in concert. Early on, one of the hemispheres is doing more work, producing more sunspots, and then that shifts later on. The other hemisphere is doing all the work. If they would be working together, we'd have a big cycle. What's cycle 25 going to do? Who knows? Might as well get a coin and flip it. I don't think we understand why the solar hemispheres don't work together. It just shows we don't understand. We understand solar cycle process. So here's real data. You know, you can make all the predictions you want, but the real data trumps predictions. The red thick line is the cycle 25 progress. It compares cycle 25 to 3 other solar cycles. The green curve is cycle 24. That's the one we just went through. It was the smallest in our lifetimes and the 4th smallest in recorded history. Orange is the an average cycle, cycle 23, in fact. And blue was a moderately big cycle, cycle 21. So it's kind of obvious what's going on so far. Cycle 25 is tracking 24. What could happen in the next several months, 6 to 12 months? We'll just have to wait and see what happens. I mentioned 56 predictions. 50 of them are for a solar cycle similar to cycle 24. So there's a general consensus amongst solar scientists that cycle 25 is going to be a small one, but who knows? The sun's going to do what it wants to do, not what we think it's going to do. So all we can do is wait and see. And even if it turns out small like cycle 24, we'll still have some great worldwide propagation around solar maximum with modest antennas and modest power. I think that's all I had. It sure is. So, whoops, what did I do? Wait a minute. Okay, Jerry, I'm done. I can.
Okay, well, I'll get Jeff to put the.
Stop.
I'll get Jeff to
Stop
put the drawing out, and maybe we'll field some questions, and we'll take it from
Okay,
there.
yeah, glad to answer any.
I don't know if there's anything
Try
in the
to.
chat.
The link's in there, and we have 10 entries so far. Carl, can you stop presenting?
So the link, Jeff, you're kind of low audio. What was
Okay.
it?
The link's in the chat, and we have 10 so far.
Yeah, I'm stopping presenting.
Okay, so the link is in the chat for everybody that wants to put your hat in the drawing. And do we have
There we go. Yeah, I stopped.
questions for Carl? Just
Let me see here.
if you unmute, please mute back up when you're done. So, question? Anybody?
We have one question that says, what is typical runtime for an antenna simulation? Minutes, hours?
Oh no, it's well, if you got a Commodore 64, might take a while. But no, a modern computer, those models ran in several seconds. If you're modeling some more intensive antennas, it could take a while, maybe 30 seconds to a minute, but most of them are the ones that I do run in a very short time. So that makes it pretty easy.
How do you find the predictions to be, or the modeling to be?
So I think
compared to
I think they're pretty good. It's hard to compare, of course. I'm not aware of a lot of people who actually measure their antenna patterns, but they seem to make the prediction, the modeling seems to make sense based on using the antennas. I should mention that we have a great way to compare antennas too nowadays. For example, if you got two antennas and you want to know, how different are they? Maybe the model predicts that one's better than the other. Well, you can use the reverse beacon network. You can transmit in a certain format, then you can go listen to software-defined radios around the world and see how strong you were, if you were being received at all. And you can, transmit on antenna A, then transmit on antenna B, and see how the signal compares somewhere around the world. And that kind of gives an indication of, it kind of would confirm the model too.
James has a question. What is the importance of radiation efficiency in a 4NEC2 simulation? And then Bill W6OAV has his hand up after that.
Yeah, okay. Well, it's important. Most of the time I don't put in the actual ohmic value of the conductors or anything because it's kind of not very important. But it all depends on how detailed you want to get. Again, the more work you put into it, well, maybe that's too much. It's important, especially for verticals on low frequencies, because you may have to load the vertical because you can't physically get it long enough. So the Q of the loading coil, and what it does is just reduces the gain of your antenna. That's what it does. Yeah, there's a good comment. Ethernet Pro with Roy Llewellyn retiring. He's made some of his EasyNet stuff free, and there's the URL for it. Dan asks, how do I determine what kind of ground conductivity I have? In the ARRL antenna book, there's a map of conductivity of North America. You could probably Google ground conductivity in North America and probably find that same map. And that's one easy way to do it. Rudy N6LF and QEX, one of the publications of the ARRL, shows how you can actually measure your ground conductivity. But I think for most of our work at HF, if you just look at the map, I think that'll give you a pretty general picture of how you're doing.
And Bill W6OAV has his hand up. Go ahead, Bill.
Yeah, okay. Good evening, Carl. Thank you for your nice presentation and joining us tonight. I had an answer for somebody who asked how the accuracy of the propagation programs are. A few years ago, I was experimenting with 2-meter dipoles and bending the ends 90 degrees to see what effect it had on the pattern. And I ran some profiles at different lengths of the bend. And then I got on a hill and with another fellow 10 miles away, direct line of sight, that had one of these fancy radios that measured actual signal levels. I went through the different antennas and they were extremely close to what the program predicted. So the accuracy, at least in VHF, is certainly good. And then I've played around with ground conductivity on HF, and it's not that critical. It doesn't make a whole lot of difference on HF. least in my experiments. So you might comment on that because maybe I was inputting the wrong information.
Well, the ground conductivity is most important for verticals, especially at lower frequencies. If you have a horizontal antenna, the ground conductivity is not that important. It's always good to have good ground, but a horizontal antenna is far less sensitive to ground than a vertical antenna, because a vertical antenna, basically the ground is providing the other half of the antenna, and that's where you can incur some losses.
Bill Worthington has his hand up. Bill, go ahead.
There we go. Let's see here. I just happen to be a geophysicist, and I have friends who have all the equipment. So if there's somebody out there who really wants to know what the conductivity in their backyard is or under their antenna, I'd be more than happy to help, because it won't conflict the work I'm doing with anything else, so I can do it. And since I'm about to retire, I won't charge, but 6-pack of beer would be nice.
Oh yeah, that'd work. Yeah. What you'll probably find is, of course, your conductivity is going to vary throughout the year. Rain's going to change it, and you may find that the ground conductivity is not homogeneous around your area.
Nope.
Too. So, the antenna modeling software has general categories of grounds: average ground, good ground, poor ground, and that's probably good enough for what we're doing here in amateur radio.
Yeah. But like I said, if somebody really has to know, I can help them out.
And then we have D. Prividel has a hand up. Go ahead.
Hi, name's Dan, KF0EGA. Thank you, Carl, for your presentation tonight. I appreciate your comments about, get something up, give it a shot, and see what happens. In contrast to many folks here, I'm just brand new at this. Got my ticket in March, and I've been trying to get off the bubble on an HF antenna. So what I like about the design or your talk is that these are simple antennas that can be used.
Yes.
Tell me a little bit more about the inverted V that you used in your example. You talked about the center mast, but you also talked about a 60-foot aluminum tower on a different antenna. What are you using as a mast for an inverted V? And then related to that, how high are your ends? I assume they don't go all the way to the ground.
Okay, good question. Well, it varies. We have an 80-foot oak tree on the east side of our property. So that's where I have my 160 meter and 80 meter inverted V at the moment. Okay, so they're about, what I did is one of the guys at work, one of the hams at work, he did a lot of tree work. So he put on all his spikes and all that and his belts and just walked up the tree, screwed in an eye bolt on one of the limbs that was extended outward. And then we hooked a pulley to it with a rope so I can rope up the antenna real easy. And the coax, no problem. So a big tree, that's one support, the support for one of my inverted Vs, or two of them. My tower with the HF log periodic, I have an 80 meter inverted V on it. It's only at 30 feet because I use that for the 80 meter traffic nets. I want it down low so it radiates at the higher angles for the shorter distances to cover Indiana and Illinois and Wisconsin for the 9th region net. And I have another little tower on the east side of the house, and it supports my 40 meter inverted V. So tree, a tower, some tubing attached to the chimney of your house, maybe. There's a variety of ways to do it, and it just depends on your specific location.
Very good. I appreciate it. Thank you.
Yeah, there's a good one about Bob Heil. Yeah, we've done field day when N9NO had a big slingshot type arrangement and shot the antenna over some of our tall trees around the property. There's other ways, and I'm sure that would be a good video to watch there in the comment from Jeff.
Okay, any other questions? How we doing with the drawing, Jeff?
26 entries so far. No, I'm sorry, 25, 25.
Okay, well, anybody that didn't get in wants to go to the chat, and we'll do the drawing here momentarily. Any final questions for Carl? Hearing none. Interesting, Carl. Yeah, you mentioned I'm mostly CW guy on HF, and I use reverse beacon all the time. It's very helpful.
Yep.
And what's funny,
Yep.
people will say, well, 10 meters has really been dead. I get on 10 meters or 15 and send out a CQ, and sometimes I'll fill up the page. I think there's 15
Yep.
spots on the page. And everybody's listening, assuming that there's nothing there and not transmitting. So I think that happens more than you really think. So that reverse beacon is really, really helpful for me anyway. So go ahead.
I think the bands are open a lot more than we think. And like you said, Jerry, the people listen and they don't transmit. So whatever. Another comment. If you've just been licensed within the last 5 years, you're probably wondering, so what's so great about 15, 12, and 10 meters, right? We were at solar minimum for a long time, and there wasn't much on. But just wait. It's starting to pick up. Unfortunately, solar cycles are 11 years long, and the average rise time's about 4 years. So it takes a while to get to solar maximum. But it'll be worth the wait when we get there. You'll have fun on 15, 12, and 10 meters on every day.
And lately, one of the nice things I found about 15 is it is really quiet compared to some, the other bands, noise-wise. At least at my location, it's very, very quiet. So that's been nice,
Mm-hmm.
and I do quite a bit on 15.
Yeah, as you move up in frequency, the man-made noise decreases, so that helps a lot. And of course, if you don't hear anything on the higher bands, try the digital modes. And what's really frustrating is, like, go to 10 meters, tune up at the FT8 frequency, and you hear some really strong FT8 signals, but there's nobody on sideband or CW, and you know that you could hear them probably. Oh well, it's
Where's
interesting
all
to
those 10-10 guys, huh?
Yeah, right.
Okay, well, if there's no further questions, we'll have Jeff spin the wheel, and we'll see who our $25 prize winner is for this evening.
So we have a total of 26 entries, and the randomized says that Bob Proctor, W0CR, is the winner, W0CR.
Bob Proctor. Well, congratulations, Bob. Haven't talked to you for a while. I'm looking for you on here. But anyway, congratulations. Kathy will get the certificate in the mail to you. And I'm sure I'm still looking for you, Bob. Well, anyway, I'm sure you're good in the roster, so we'll get it off to you.
He just responded in the chat. Thank you very much.
Okay, maybe 0CR. Okay. Okay. Real good. Congratulations,
Jimmy,
Bob. Oh, no
Uh,
mic. Okay.
W6OAV, you raise your hand.
Yes, I just wanted to break in here. Bill Worthington, can you send me your email address?
Sure. Hang on.
W6OAV@arl.net.
Okay.
I got a question for you. Thank you.
Okay.
All righty. Well, I guess that brings us to the end.
Okay, thanks.
Go ahead.
Okay, thanks to everyone. And, it's 10 o'clock here,
Okay. Well,
so
thank you for the
gotta go find the
presentation.
cat. All right.
Kick the cat out. All right.
Yeah.
Thanks again.
All right. Okay.
Interesting
Bye-bye.
presentation. If you got something else sometime for us, I'll let Bill work that out with you. So 7-3 to all, and we'll see you next time. Adios.
Okay.